So this is the plate from the phase 2 that goes into the T-slot on the compound slide. And you can see it's a monster compared to the one that came with the Grizzly. And the instructions say that you may have to machine it down to make it fit your T-slot. And that's true. And I have no way to do that right now. So the phase 2 will have to wait. Which is okay, because that'll give me a chance to show you the tool post that came with the machine. You can easily unlock it, and it's got a little spring-loaded plunger with an angle on one side in the compound slide that sticks up, and there are some slots in the bottom of the tool rest, or the tool post, which acts kind of like a ratchet. I can't turn it this way, but I can turn it this way. Or I can make it perpendicular to the spindle axis, or parallel to the spindle axis, however you look at it. And the idea with this tool post is that you would have a bit here, tighten these two down. You could have another bit here, tighten those two, another bit here, tighten those two. You can have it to 4 bits and change bits just by loosening this and rotating to the bit that you want. Lock it down. You can see there's no height adjustment here. The instruction book says to use shims to adjust each bit. Definitely a pain in the neck compared to the phase 2 or an Aloris or maybe other brands. But it came with the machine. It's not a super expensive machine, so that's not surprising. But once you get a bit shimmed, and you'd need to shim a different thickness bit, a 1/4 by 1/4 bit, or 5/16 or 3/8 or 1/2 inch, you'd need to shim each one a different amount, and maybe depending how you grind it, shim it a different amount. But once you've done that, then you could pick any of these 4 bits real quickly and use it. So it's not, certainly isn't the end of the world, and that's what I'll use for the time being, and that's fine. But eventually I'll get that plate machined for the phase 2 and use that tool post instead. I just ground my first 2 bits, and it was a lot of work and almost burned my fingers countless times, and it took a long time. The bit on the left here is for threading. That's a 60-degree angle, and I spent 20 bucks on a brand new Starrett thread gauge, so I can get that 60-degree angle right. When I ground that bit on my first attempt, that leading edge angle was straight up and down, and I recalled that I needed it to go to the rear to give relief under the cut, so I just reground that a little bit. This bit I started on this end and it didn't turn out too good, so I did it from scratch on this end, and it's not perfect by a long shot. This is just a facing bit. I think it's okay. I'll give it a shot. But grinding bits is definitely a skill you've got to practice and learn. And my first attempt was just a ton of work with imperfect results. But actually, this is my second attempt on the threading bit, and I'm really happy with it. I think it's pretty darn good. My second attempt on the facing bit is so-so. So we'll give it a shot and see how it works, and I'll do some more grinding and learn how to do it and get it down. I got the backsplash painted and added that, so that's on there now. Hopefully it'll help keep the room a little bit cleaner. And you may have been wondering why I've got all this space behind the lathe. The instruction manual recommends 30 inches behind the machine. You need space on this end of the machine to open the door, and they recommend 30 inches behind it for maintenance. And if you ever had to work on the motor or the electronics you definitely want space behind it. Like I said before, you do not want to move this thing. You may also notice I didn't paint the back of that backsplash. This used a whole can of spray paint, and that's good enough. This is all that I'll see 99% of the time. So you don't want to have to move this machine, so you definitely want to give yourself some space behind it. I'll use this for storage, usually, probably. And if I need to do any work on the electronics of the motor, I'll be really glad I've got the space. You may have noticed this the other day. If I open that up, there's the spindle, and you can see right through it. So what you can do is, if you have a long workpiece, you can run it right through the spindle. So you might have a long piece of metal, and in fact I'm going to put one in the machine shortly. And so you don't have to cut it off and make it short. Even though these pieces, the end result will be really, really short pieces, I don't want to cut my brand new 4-foot pieces of aluminum bar into small chunks. I just want to leave them whole and snip off whatever I need. So those pieces will just come protruding all the way out here. In fact, let me do that right now. So this is 3/4 inch material. It's 6061 aluminum. And you just shove it in the end here. And it should just come on through here. Yep, I see it in there. And there it is. So that's a 4-foot piece poking out there, and then it just comes sticking away out here. So this will be the first time I've had any metal in the machine. There, that's pretty sturdy. Let's see what happens when I run it. I'm going to machine this, by my calculation, it should be about 1300 RPM. Should give me around 250 surface feet per minute. And hopefully that doesn't start flopping around and flailing and destroying the house. It actually does kind of wobble. I guess that's it. It's not going to get any worse than that, I guess. So, that doesn't seem ideal, but it also doesn't seem terrible. It's kind of a long, skinny piece. It might be worth just chopping it in half. Anyway, we'll see. So, I'm going to try out my new bits. I think I'll face this thing, and then I think I'm going to try threading. I've always wanted to try threading on a lathe. That seems cool, so I'm going to give that a shot. See if my bits work at all. So you can see how much lower the bit is than the center of the workpiece. You want the bit, the cutting edge of the bit, to be on the center of the workpiece. So this edge right here, I want it to be centered right here, halfway between the bottom and the top. So that's going to take a lot of shimming. I may just see if I can put another tool or bit blank under it. Anyway, I'll do a bunch of shimming and get that thing lined up so I can face this piece. The end of it's mushroomed a little bit, so it'll take maybe several facing passes to get down to a clean part of it, which is great. I'll get to test my tool on several passes here. So I just used a big pile of feeler gauges. So I got a couple extra feeler gauges lying around, unscrewed the screw and took them all out and just put a big stack in there, and that's pretty close to centered. I do not like this shimming thing one single bit, so I'll be glad when I can get that phase 2 tool post installed. But for now, that's the deal. Obviously, this is a 1/4 inch blank, or it was a 1/4 inch blank. With a 1/2 inch blank, for example, you'd need to do a whole lot less shimming, so that would be one argument in favor of a 1/2 inch bit. Take more grinding, but presumably I'll get better at grinding the more I do it, and that won't be as big a deal. For now, grinding a 1/2 inch bit would be a lot of work. But ultimately, I think that would be easier to mount because it would eliminate maybe the majority of these shims, and I don't like all those shims in there. Anyway, that's the deal. So let's see. That's where we're at. A little bit low. Hey, I'm still alive. The machine didn't explode. The aluminum rod didn't go crazy. It's just vibrating a little bit. Obviously, tool post is a little bit low, but cool. I'm machined. I'm a machinist. All right, I use that whole pile of shims or feeler gauges. I'll grab a couple more out of the garage and get this thing lined up properly and take another whack at it. So I put a few more shims in there, and I think we're good to go. So let me do a little more facing because there's still some of the mushrooming at the end here, so I still need to get maybe 1/8 of an inch off of there, so let's do a few more passes. think maybe I should have the cutter. Ooh, that's fine. It's finer than steel wool. I think maybe I should have the cutter at a little more of an angle to the workpiece. It's difficult to start the facing from the center when it's as straight as it is. So let's try that. There's still a tiny little nub there, really, really tiny. So I'm not quite centered, but not bad for my first try. Let's try threading. That should be interesting. Since I would need bigger material than this to make a nut, I'm not even going to worry about how many teeth per inch I'm doing here. I just want to cut some threads. It's just for fun to see how it works. And what I'm planning on doing is not using the threading dial, the little spinning dial that engages the lead screw. I'm just going to try using forward and then reverse and see if that works. So this is just kind of a fun experiment to see what happens. Not real important. I'll just thread a couple inches and see how it goes. Actually, I think I'll back this out a little bit. So I'll let it go maybe 2 inches and then use the forward reverse switch to kill the power and then reverse it. And let's see if I make some threads. And this is aluminum, so should cut real easily. Alright, here goes nothing. I just slowed the spindle speed down, left the belt on the medium pulleys, so it should be spinning about 160 RPM. Alright, don't forget to stop the rotation. Alright, now I'm going to close the half nut. I don't even think it's touching. Alright. So let's go in with the cross slide a little bit. I'm just going to leave the half nut engaged for this entire experiment. Nope, still not touching. In with the cross slide. There we go. Okay, that's a finer thread than I want to cut, so I'm going to pick a different combination of the dials here. Actually, I think I'm going to need to change the gears to make this thing go faster. I did all kinds of crazy gear swaps and I need to come up with maybe a little jig and a rod that I can use to pound out the. It's a sleeve that hooks two gears together with a Woodruff key, I guess, or some kind of a square key, and it's pretty tight in some of the gears, so I need to make a little just a piece of wood with a hole in it that thing can fit through, and then maybe out of this aluminum something that's just a hair smaller than that diameter, so I can pound on this with a hammer and pound that thing out. It's just a pain in the neck. Anyway, did all kinds of crazy gear changes, and now the lead screw is spinning at a much faster pace relative to the chuck than it was before. So, and I did one test cut, and this is exactly the kind of thing I was hoping I'd be able to do. This is pretty cool. Well, of course, now my thread's going to be off because I didn't keep track of where I was starting it. Let me see. Well, yeah, it's still going to be messed up now because I'm not coordinated with the lead screw, but I'll still make a few cuts just for fun. Maybe I'll try my reversal thing here now too. Yeah, I'm off just a little bit compared to my initial cut. That's alright, I'm just messing around. Now let's go in reverse. It should stay in its old track. And go in on the cross slide, 10 thousandths. And eventually, I think the cut will be deep enough that those two threads that I've got will become one. So it'll maybe end up looking interesting. In 10 thousandths, and I'm just using the cross slide. I know normally at this place in making threads you'd use the compound to go in, but I'm just playing around, so I don't care. Just fiddling around. In 10 thousandths on the cross slide. Actually, I'll go ahead and use the compound. Alright, let's see. I'll set it on 0, I think. Alright, we'll go in 10 on the compound. May as well get in the habit of doing it right. And actually, I'm going to set the cross slide, set it to 0. Alright, now I'll come out one full revolution of the cross slide. Again, I'm just actually 2 revolutions of the cross slide. Oh, you know what? I'm not using the threading dial, so never mind. I can't do it that way, or I'm going to be off on my threads again. So there's that. Alright, now reverse. So I gotta keep doing this the same way, since I'm not using the threading dial. Alright, in on the cross slide. Or actually I can go in on the compound. in the compound, another 10 thousandths. Oops, wrong way. And the spindle's turning at 114 RPM. And in the compound, another 10. And since this is just 3/4 and sticking out kind of far here, there's definitely some spring action going on. You'll see here, I didn't move the compound in at all, and it's still taking, or maybe you can't tell, it's still taking a pretty good cut there just because of the spring in the piece of work. But again, I'm just having fun here, so it's no big deal. So there's my first threading job. I have no idea what pitch it is, but it was fun. There was a lot of spring way out here on the end, and definitely less spring here at the root of the thread, or whatever you'd call this end. Anyway, that was cool. Just the experiment I wanted to do. That was fun. Of course, the right way to do it is to use this gizmo, back off the cross slide, come back, move the cross slide back in to what it was before, and then move the compound in a couple thousandths, and then start the auto feed when the correct number comes around here for the thread that you're cutting. I'll do it the correct way sometime, but this was kind of a fun way to get started threading, just to experiment. Also, when you change your chuck, remove a chuck, put a new chuck on, whatever, you're supposed to put a piece of wood over the bed so that in the event that you dropped the chuck, you won't damage the ways. So I just used some scrap wood, put a couple spacers on there that fit between the ways, and it just fits right on there like that, so it'll stay put for the most part. So when I take a chuck on and off, I've got some place I can set it, or if I drop it, it'll just hit this piece of 3/4 inch plywood. And that's it. Grizzly G0752. So far, it seems pretty cool, and I think I'll get a lot of good use out of it, hopefully.